Okay, good morning, student. Now, a previous session we covered the amplitude modulation and how the amplitude modulated signal in time domain as well as in frequency domain. What is the bandwidth and power calculations? Okay, we'll solve a few problems on singletone AM and multitone AM. Okay, now you already covered the mathematical analysis of singletone AM and multitone AM. Now we will see in this session how the AM wave is generated. What are the AM modulators? Okay, what are the AM generation techniques? Okay, in amplitude modulation, now we'll see the AM modulators. AM modulators or generations of AM waves. Okay, AM modulators are generations of AM waves. Now see here, this is AM modulator. Square law modulator. What is this? Square law modulator. Okay. Now there is another name for this square law modulator. Now this is a square law modulator, and this is also named as square law modulator, or also called as. Okay. What is another name? We will see. Now see here. Before that, just give a few important points here. Now this is the linear device. This is a linear device. Now this is input x of t. This is output y of t. Now what is the relation between input and output? Now input is x of t, output is y of t. Therefore, now y of t is directly proportional to x of t. If you remove this proportionality constant, proportional to put a constant a naught into x of t. Now this is the linear relation between input and output. This is a non-linear device. Now this is input x of t, and this is output y of t. Now this is a non-linear device and producing the non-linear characteristics and harmonics. Now this is y of t, which is equal to a naught x of t plus a1 x square of t plus a2 x cube of t plus and so on. Is it right or not? Plus and so on. These are the non-linear characteristics, right? Now here the point is, now this is the linear device and this is the non-linear device. Such type of a non-linear devices, diodes or transistors. Now such type of a non-linear devices are used to generate an AM signal. Now this square law modulator is also called as non-linear modulator. This is also called as non-linear modulator. This square law modulator is also called as non-linear modulator. Now this is the square law modulator, or also called as non-linear modulator. Okay. Now, but why the name is square law modulator? Why it is coming as a square law modulator? But if this is a non-linear device, if I am taking, of course it is a non-linear relation, but it will take a infinite number of harmonics. Am I not? Now, if this is cos 2 pi fct, cos 2 pi ft is the input, frequency is f at the input side. What is the frequency at the output side? A naught into, what is this? This is A naught into cos 2 pi ft. Therefore, the frequency at the output side is also f. The frequency at the output side is also f. Therefore, frequency at the input side is f, our output side is also f. But what about here? Now here, if the input side is cos 2 pi ft, So frequency at the input side is f. But what are the frequencies present at the output side? Now here it is f square, 2f cube, 3f, and so on. A number of harmonic components, right? So at that many number of calculations which are very difficult, because infinite number of components we are taking if it is a non-linear device. Therefore, instead of that, what we are doing is same non-linear device. There is no other change. Now this is the non-linear device. Now this is input x of t, and this is output y of t. So this y of t, which is equal to a naught into x of t plus a1 into x square of t. Okay. In order to avoid this number of calculations part, I just take two components. I just take up to the second harmonic. This is also not a linear device. This is a non-linear device. Okay, because it is not a linear relation. So, but I just limiting the calculations part. I just take the two harmonics and generate the AM wave. That's why this is called as two components. This is the first harmonic, second harmonic. So that's why this nonlinear device, which we call it as a square law device. This is a square law device. That's why that modulator is named as square law modulator, or called as a non-linear modulator. This is one GATE examination question. Square law modulator is a options: linear modulator, non-linear modulator, none of the above, like that the options are available. Square law modulator is a non-linear modulator, now which involves a non-linear device. But for restricting the calculations part, I just take the second harmonic. Okay, that's why this is a square law device. Okay, now we use this type of a device and generate an AM signal. Now that particular modulator is called as square law modulator. No doubt. Now this is the message signal, and this is the carrier signal. This is the message signal, and this is the carrier signal. Now, because for modulation we require both message signal as well as a carrier signal. Now let us assume this is some Vi input to the square law device, and this is V naught output to the square law device. Now what is Vi here? Now this is a summation. Message signal carrier is applied to the adder. So what is Vi? Now Vi, which is nothing but, now what is V naught? This is a square law device. A naught into Vi plus A1 into Vi square. So this is Vi which is equal to m of t plus AC cos 2 pi fct. M of t plus AC cos 2 pi fct. So what is V naught? V naught, which is equal to A naught into Vi plus A1 into Vi square. Now which is nothing but V naught, which is equal to A naught into Vi. Vi is m of t plus A naught into AC cos 2 pi fct plus 2 pi fct plus A1 into Vi square, A1 into m square of t plus A1 into AC square cos square 2 pi fct plus A1 into 2 m of t AC cos 2 pi FCT. Right? Now this is the output of the square law device V naught. But if you observe here, what are the components here? Now message signal frequency, carrier, and message signal square and carrier square. What are the components you are expecting at the output of the modulator? So we want AM signal. AM signal is nothing but carrier, upper sideband, lower sideband. So carrier, upper sideband, lower sideband we want. Therefore, this output of the square law device is passed through a band pass filter, and you design a band pass filter whose gain versus frequency characteristics like this. Whose gain versus frequency characteristics are, now pass band is from FC minus FM to FC plus FM and a center frequency of EFC. So if you design a gain versus frequency characteristics of a band pass filter with a pass band of this, FC minus FM, FC plus FM. Now this is the output of the square law device, which is equal to A naught into M of t plus A naught into AC cos 2 pi FCT plus. Now see here. Now this is a message signal of frequency FM, which is not allowed by your band pass filter. FM is not allowed. Now this is a carrier signal of frequency FC within the pass band. Therefore, this is allowed by your band pass filter. Now this is signal is square, frequency is double, 2 FM is not allowed by your band pass filter. Now here this is 2FC is also not allowed by your band pass filter. But now if you see here, cos A, cos B, this is cos 2 pi FM into T. Cos A, cos B, 2 cos A, cos B. Cos of A plus B plus cos of A minus B. Therefore, FC plus FM, FC minus FM. FC plus or minus FM. FC plus FM, FC minus FM. Now this is a band pass filter is allowed. So what is the output of the band pass filter finally? The output of the band pass filter, is A naught AC cos 2 pi FCT plus A1 2 M of t into AC cos 2 pi FCT. Now AC cos 2 pi FCT, if you take it as a common, AC cos 2 pi FCT, if you take it as a common, 1 plus 2 A1 by A naught into M of t into cos 2 pi FCT. This is A naught. So this is the output of the band pass filter. Now see here, now some scaling. If this is a Now this is A naught into X. Therefore, now you want to eliminate A naught. So that A naught into X you can easily eliminate it. Now this is some A naught into X. You want to cancel A naught. Therefore, now what should we do? You just pass through an amplifier. This is passing through an amplifier circuit. This is passing through an amplifier circuit whose gain which is equal to 1 by A naught. Whose gain which is equal to 1 by A naught. Now this is A naught cancel, which is X. Now what is X here? Now the output of square law modulator is finally, the output of square law modulator is AC into 1 plus 2A1 by A naught into m of t into cos 2 pi fc t. This is the output of the square law modulator. And students, what is the output of what is the AM signal? What is the standard mathematical time domain equation of AM? The standard mathematical time domain equation of AM is AC into 1 plus Ka into m of t into cos 2 pi fct. This is the standard AM, and this is the equation which is generated from the square law modulator. Both are matching or not? Therefore, this is an AM wave. This square law modulator is generating an AM signal, where here, what is this? Here Ka, the Ka which is equal to 2A1 by A naught, which is the sensitivity of square law modulator. Sensitivity of square law modulator. This is the sensitivity of square law modulator. See here, this is the sensitivity of square law modulator to A1 by A naught, and this is the generation of AM. This square law modulator is able to generate an AM signal. Understand now? This is a square law modulator now which is able to generate an AM signal. This is the output of square law modulator, which is nothing but X. Now this is X is nothing but this one. Okay, note down this, very important. Now classroom workbook question number 11. Classroom workbook question number 11. Consider a square law modulator. Consider a square law modulator as shown in the figure below. So in this question, he is giving the square law modulator. Okay, consider a square law modulator as shown in the figure below, and he is giving this square law modulator. Consider a square law modulator as shown in the figure below. Now this is the square law modulator which is already given to you. Consider a square law modulator as shown in the figure below, and output of the square law device is already given. Now in this question, he is given the square law device output also. If he is not given, then you take the square law device output as a true harmonic. But in the question is given square law device output also. The output of the square law device is given, is this. So you utilize that. And it is passing through an ideal band pass filter, and it is passing through ideal band pass filter whose pass band is passing through an ideal band pass filter. He is giving a pass band characteristics also. He is given an ideal band pass filter and whose pass band is from 800 Hz to 1200 Hz. Now he is giving a pass band of band pass filter, and which band pass filter? Ideal characteristic, sharp cutoff frequency. Okay. Now this is the band pass filter characteristics is also given. and what he is asking is finally, by consider this square law modulator, he is asking to determine bandwidth, power, and modulation index. He is asking bandwidth, power, so all powers, and modulation index. Okay, so this is the parameters he is asking, how to find bandwidth, power, and modulation index. Okay, now first you just observe here, we'll go for our normal procedure. Now here I will write. Okay, now what is Vi? Input to the square law device. The input to the square law device, which is 4 cos 2 pi into 100 into t plus 10 cos 2 pi into 1000 into t. Okay, so this is the input to the square law device. What is V naught? V naught, which is nothing but V naught, which is Vi. This is Vi. Vi is nothing but as it is 4 cos 2 pi into 100 into t plus 10 cos 2 pi into 1000 into t plus 0.1 into Vi square. Vi square means 4 square. 4 square means 16. 16 into 0.1. 1.6 cos square 2 pi into 100 into t plus 10 square 100 into 0.1. 10 into cos square 2 pi into 1000 into t, right? Now plus 2ab, 2 into 4, 8 into 10, 80 into 0.1, 8 cos 2 pi into 1000 into t cos 2 pi into 100 into t. Now this is the square law device output is passing through a band pass filter, and whose pass band is from 800 Hz to 1200 Hz, right? Now see here. Now what is the frequency? 100 Hz within the stop band, not allowed. What is the frequency? Square 200, not allowed. 2000, not allowed. Now this is 2000, this is 200, which is not allowed by our band pass filter, and this is 100, which is not allowed band pass filter. What about this? So can I take like this? Now this is 4. If I write 4 into 2, 2 cos A cos B. What is 2 cos A cos B? Now 1000 and 100. Now here it is 1100. Here it is 100, 1000 minus 100, which is 900. Okay, 2 cos A cos B, cos of A plus B. Now cos of A minus B, right? 1100 and 1100, 900 is within the pass band, and here 1000 are within the pass band. Therefore, this is allowed. This is allowed, and remaining parameters which are not allowed by your band pass filter. Now, what is the output of the square law device? Now, finally, the output of square law modulator is the output of square law modulator, which is 10 cos 2 pi into 1000 into t. Then this is 2 cos A cos B, 4 into cos of A plus B, cos 2 pi 1100 into t plus 4 cos 2 pi. Now 1100 minus, now this is 900 into t. Now cos A cos B, cos of A plus B, cos of A minus B. Now see here. Now can you see somewhere this equation? AC cos 2 pi FCT plus AC mu by 2 into cos 2 pi FC plus FM into T plus AC mu by 2 into cos 2 pi FC minus Fm into T. Now AC, which is equal to 10 volts. Now AC mu by 2, which is equal to 4. Therefore mu equal to 8 by AC, which is equal to 8 by AC is 10, which is 0.8. Now upper side band. What is upper side band? Now Fc plus Fm, upper side band Fc plus Fm, which is 1100 hertz. Lower side band Fc minus Fm, lower side band Fc minus Fm, which is equal to 900 hertz. Therefore, now the bandwidth which is equal to upper side band minus lower side band. The bandwidth which is equal to upper side band minus lower side band. The bandwidth which is equal to 1100 minus 900, which is equal to 200 hertz, is the bandwidth. Okay. Now this is the bandwidth which is 200 hertz. Now bandwidth is calculated, modulation index is calculated, and all the powers which we can easily calculate it. Now what are the powers? The powers which is nothing but carrier power AC square by 2R, which is equal to 10 into 10 by 2 into R is 1 ohm, normalized power, therefore which is equal to 50 watt. Next, total power. Now the total power which is equal to PC into 1 plus mu square by 2, and the sideband power which is equal to PC into mu square by 2. All parameters are available. You can easily calculate it. Okay, note on this. And now students are asking the question that, sir, in the gate examination for 1 or 2 marks, now this much lengthy calculations which are difficult. No, yes, this is definitely you are saying this correct, which is difficult. Now this is a method 1, general method. Now what is this? This is the general procedure. This is method 1, general method. Now what do you want? You want a shortcut method, right? Yes. Now sir, we want a shortcut method. Directly answer I want, sir. Yes. Not a problem. You can easily find. So what is given to you? He is given. Now see here. Now the shortcut method I am explaining. You just concentrate on carefully all the answers. Okay. Now this is 4 cos 200 pi t, right? Which is nothing but am cos 2 pi fm into t. Now from here you can identify what is fm. Fm equal to 100 hertz. Now one more is also given, 10 cos 2 pi into 2000 pi t. Now which is nothing but this is high frequency, carrier AC cos 2 pi fct. From here fc which is equal to 1000 hertz. Why not? Now this is carrier frequency. What is AM? AM which is equal to 4 volts. What is AC? AC which is equal to 10 volts. Now, sir, for finding everything we require a modulation index, sir. How to get that? Yes, you can get. What is the equation which is already given to you? Now, square law equation is given, no? V naught, which is equal to Vi plus 0.1 into Vi square. General square law equation is what? Now, the general square law equation which is equal to V naught into A naught into Vi plus A1 into Vi square. Am I not? A1 into Vi square. So what is the sensitivity of the square law modulator? What is the sensitivity of the square law modulator? Ka, which is equal to 2A1 by A0. Just now we are already derived that, right? Now 2 into what is A1? Compare. A1 is 0.1 by A0. What is A0? A0 is 1. So which is equal to 0.2. What is the modulation index? The modulation index mu, which is equal to Ka into AM. Ka is 0.2 into AM. Amplitude of the message signal is here 4, which is equal to 0.8. This is the modulation index mu. So now what is AC? AC is available, which is equal to 10 volts, right? AC is available, modulation index is AC and modulation index both are matching, then all the remaining calculations you can easily. Okay. Now which in 1 second you can easily find. Now this is the shortcut method for question number 1 and this is the general method for question number 11. Sorry. Okay. Note down. Now this is classroom workbook question number 12. But in this question, he is not giving this particular block diagram and all these things are not given. Okay. Now he is just giving the statement. What is the statement? A message signal. Now question number 12 is a message signal of 5 volts amplitude and a carrier signal of 1 volt amplitude. A message signal of 5 volt amplitude, a carrier signal of 1 volt amplitude are added. A message signal of 5 volt amplitude and a carrier signal of 1 volt amplitude. Okay, a message signal of 5 volt amplitude, a carrier signal of 1 volt amplitude are added each other and is applied to the square law device. Are added each other and applied to the square law device. It means that now this is AM cos 2 pi FMT. Just for easiness, I just draw the diagram, but he is not giving any diagram. A carrier signal means AC of cos 2 pi FCT. A message signal and a carrier signal are added each other. AC cos 2 pi FCT. AC cos 2 pi FMT. A message signal and a carrier signal. Signal means here. A message signal or a carrier signal are added each other and is applied to the square law device. And whose square law equation is? Whose square law equation? Square law equation is also given here. Now that square law equation, what is given is I naught current in terms of current 10 plus K1 into Vi plus K2 into Vi square milliamps. Okay. Now this is output of the square law device. Now which is I naught, which is equal to 10 plus K1 into Vi plus K2 into Vi square. Now where Vi is the input to the square law device. Okay. Now this is a passing through a band pass filter. So what he is asking? He is asking to find modulation efficiency. What he is asking? He is asking to find modulation efficiency. Now how to find the modulation efficiency? So now see here. Now this is the output of the square law device and he is giving this K1 which is equal to 2 milliamps per volt and K2 which is equal to 0.2 milliamp per volt square. Now this is the square law device output of the square law device which is equal to 10 plus K1 into Vi plus K2 into Vi square milliamp. Now what he is asking? He is asking to find modulation efficiency. He is asking to find the modulation efficiency. Now see here how to find this. Now this is the square law modulator which we can easily understand. So what is Ka? Now this shortcut method you follow. What is Ka? Ka which is equal to 2A1 by A0. Now here which is equal to 2K2 by K1 which is equal to 2 into. Now 2 into what is K2? K2 is 0.2 by K1 is 2. Therefore K is 0.2. Now what is the modulation index? The modulation index which is equal to Ka into AM which is equal to Ka. What is Ka? 0.2 into amplitude of the message signal. Amplitude of the message signal is 5. 0.1. Right? When the modulation index is 0.1, you can easily find what is the modulation efficiency which is equal to mu square by 2 plus mu square which is equal to 0.1 whole square by 2 plus 0.1 whole square. You can easily find. Okay. Now this is the modulation efficiency, right? Now you can easily find the modulation index. Okay. There is no diagram, nothing is given. Only the square law equation is given. A message signal of amplitude 5 volts is given. A carrier signal of amplitude 1 volt is given. You can find. Not, but he is asking only this. But you can find anything because here carrier amplitude is also given and modulation index is also given. You can find the powers also, it's not a problem, okay, but he's asking only this one, you can easily find. What is the carrier power? The carrier power, which is equal to AC square by 2R. AC is 1 into 1 by 2, R equal to 1 by 2, which is equal to 0.5 watt. Now the total power, which is equal to PC into 1 plus mu square by 2, which is equal to 0.5 into 1 plus mu is 0.1 whole square by 2. And the sideband power, which is equal to PC into mu square by 2. So you can find everything, okay. No doubt. Generation of AM signal. Now, what is the output of the transmitter? The output of the transmitter is an AM signal, right? So, input is a message signal and a carrier is added, modulation is done, output of the transmitter is an amplitude modulated signal. Now, that AM signal is transmitting through the channel. Now, we are at the receiving side. What is input to the receiver? The input to the receiver is nothing but an amplitude modulated signal. But can we understand at the receiver? We are the persons at the receiver. We cannot understand the modulated signal. We can understand only a low frequency information signal. Okay. So the input to the receiver is a modulated signal, but output of the receiver, what we are expected as a message signal, which is a low frequency information signal. So the input to the receiver is a modulated signal. Now from that modulated signal, then I want to get back my original message signal. So you just do the exact reverse process of modulation. Now that is nothing but demodulation. So now we will see AM demodulators. AM demodulators. What are the AM demodulators? What are the different types of AM demodulators? Okay. Now just know exactly the reverse operation which we are already saying, right? So what is the AM modulator? The AM modulator is nothing but a square law modulator. Therefore, the AM demodulator is nothing but, there are three demodulators here. The first one is, just know you finish the square law modulator. Therefore, this is nothing but square law demodulator. Square law demodulator. And the second one is envelope detector. Envelope detector. And the third one is synchronous detector. Okay, square law demodulator, envelope detector, and synchronous detector. These are the three demodulators. Means for all the demodulators, one simple way I will explain this. What is a demodulator? For all the demodulator techniques, input is modulated signal, amplitude modulated signal. What we are expected, the output is information signal, which is nothing but message signal. So what should be the procedure involved in this particular demodulation technique, such that we can easily get back our original message signal? Okay, that's what we concentrate here. What are the AM demodulators? What is square law? What is envelope? What is synchronous? Now, how this will be get back the original message signal from this demodulation technique? Okay. Now, how the square law demodulator is working, how the envelope detector is working, how the synchronous detector is working. Now we want to see what are the procedure involved here, right? Now, what are the components which is involved? Now, what is the procedure to get back the message signal? Okay, we will cover all these things in square law demodulator, envelope detector, and synchronous detector. Okay, hold on.